MA087 4.5, chapter 4.5, real numbers. Okay, in this section we will learn what the definition of real numbers and what real numbers is composed of, what numbers. Okay, so okay, let's check the rational number first. Okay, a rational number is a quotient of two integers. Okay, rational number is a quotient of two integers. What do you mean by that? It's a fraction. So like a 3 over 4, 3/4. So the quotient of 3 and 4 is a fraction, 3 over 4, right? Or -2 over 5, 4 over -7, or 3 over 1. Okay, 3 over 1, the denominator is 1. So 3 is also a rational number because you can write 3 as 3 over 1, right? So 3, integer, is also a rational number. So we can write it like this. Rational number is composed of two types. One is, real numbers. Okay, real numbers is composed of two types. One is rational number and the other one is irrational number. Okay, so so two of them. So rational numbers is the ones that you can write in fraction, like 1, integers 1, like 1 over 2, 1/3, or 3 over 4, or square root of 4. What is square root of 4? Okay, once you simplify this, then it becomes what? Integer, right? Integer is also a rational number. And the irrational numbers are ones that cannot be written in a fraction. So actually rational numbers, once you write a number in decimal, then this number is non-terminating and non-repeating. So square root of 2, for example, square root of 2, the value is 1.414, and it keep going, right? Keep going. It does not stop, does not terminate. Terminate means it stops. So that is the end point. But in this case, it goes forever and it does not repeat. Even square root of 3 and square root of 5. So all the square roots, who is not a perfect square, whose radical is not a perfect square, then they are rational numbers. Even the symbol pi is 3.14 and so on. So okay, let's learn more about the rational numbers and irrational numbers. Okay, so every integer is a rational number. So integer has 1 as a denominator, so it is one of the fractions. So 5 is 5. The integer 5 is a rational number. -7 is also a rational number. Okay, and then also the mixed number. So all the mixed numbers are also rational numbers. So 1 and 4/7 means you can write this one as a fraction, 11 over 4, right? 1 times 7 plus 4 is 11 over 4. 3 and 4/5 also what? Rational number, because you can write it in a fraction, in proper fraction. So still okay, right? How about this? 3/8. Okay, 3/8 is an improper fraction. 3/8 is a fraction. So yes, it is a rational number. Okay, then the rational number is either terminating decimal or repeating decimal. Okay, which means terminating means 3 over 8 means you divide the numerator by the denominator 8. So 3 over 8 is equivalent to 3 divided by 8. So 3 divided by 8, then the decimal number is 0.375. And then it stops. It terminates. It terminates at 5. So 1,000th, right? It terminates. So we call this number a terminating decimal. Terminating decimal. Okay, how about 6 over 11? 6 over 11 is a rational number, But when you divide 6 by 11, it looks like this: 0.54545454 and so on. So these two digits are repeating. So when digits are repeating, we put bar above the repeating number 54. So this means 54 is keep repeating. It does not terminate, right? This does not terminate, but it repeats. So when a repeating decimal, there's a repeating decimal, then that number is also rational number. It's a rational number. So every rational number can be written as either what? Terminating decimal or repeating decimal. Vice versa, all the terminating and the repeating decimals are rational numbers. Okay, so it's really simple. Real numbers are composed of rational numbers and irrational numbers. Rational numbers are fractions, so that the fractions can be terminating decimal or repeating decimal. So repeating decimal means it's not terminating, right? And the irrational numbers are what? These are the decimal numbers that are non-terminating and non-repeating. Non-terminating, non-repeating. So there's more definitions here. So rational numbers. So an irrational number is a number whose decimal representation never what? Terminates. So non-terminating decimal, or never repeat, right? So non-repeating decimal. So the symbol pi, 3.141 and so on. This never terminate, never repeat. Square root of 3, 1.74205 and so on. Never terminate, never repeat. How about this decimal? Okay, you have 0.23, right? And next one is 2, then 2 threes. 3, 3. And then next what? 2, 3, 3, 3. 2, then 3, 3, 3, 3, and so on. This one never repeats, never terminates. So these numbers are irrational numbers. So since the rational numbers is composed of rational and irrational, real numbers. Okay, real numbers is composed of rational and irrational numbers. Real numbers are all the rational numbers together with all the irrational numbers. Make sense? So the number line, do you remember the number line? So this number line is also what? Real number lines, right? Real number lines. So all the numbers, all the points in this number line is either rational number or irrational number. So rational or irrational number. So when you put all this together, then it forms a straight line. Real number line. Okay. All right. So let's check. Draw a diagram. Hierarchy diagram. So real numbers is the number in the real number line, right? And this number is either rational numbers or irrational numbers. And irrational numbers are very simple: never repeat, never terminate. And rational numbers is really simple. Rational numbers are what? Fractions, right? Fractions. So those fractions can be separated into two groups. One is integers, and the other one is fractions that cannot be reduced to integers, right? So either a fraction or integers. And the integers is really simple. It's either negative integers or 0 and positive integers, right? So negative integers and 0 positive integers. And 0 and positive integers are called what? Whole numbers, right? Whole numbers. So the whole numbers is composed of 0 and positive numbers, and positive numbers is also called rational numbers. Do you remember this part? We learned this one already, right? Okay, so real numbers are what? Rational numbers and irrational numbers. Rational numbers are what? Fractions. Okay, so the number line. Okay, the number line is also called what? The real number line, because this number line contains either rational or irrational, which is a real number. Okay, so now graph this point, graph 3.5 on the real number line. So we have a real number line and 3. So this number 3.5. Okay, this one is greater than 0, right? So if a number is greater than 0 or greater than a number, then it's always on the right side of the number. So 3 is greater than 0, so as you go to the right, the number increases. As you go to the left, the number decreases. So 3.5 is, here's number 3, and the half means half, right? Half of 1 unit. So this part, right between, in the middle of 3 and 4. So this is the 3.5. Right? 1/2 is middle of 1 unit. Alright, so then how about can you plot this point, negative 2.5? Negative 2.5. So how about, where's negative 2.5? Okay, negative 2 is over here, right? This is negative 2. And negative 2.5 is less than negative 2 because it's left of negative 2. So negative 2 is here, and then negative 2.5 is between negative 2 and negative 3, right? So this is the location of negative 2.5. Alright, then how about this one? Okay, graph the real numbers that are greater than 2. So let's say x is a real number. So 2, where's 2? 2 is over here, right? This is 2, right? This is 2. So greater than the number is, these are all the numbers that is right off this number 2. So all the numbers right off this 2, right? So all the numbers in this region, in this area. So these numbers are greater than 2 because they are right off this number. And then 2 is not included because greater than means 2 is not included. So if it's not included, then you can put a parenthesis. Okay, parenthesis means use parenthesis. This means do not include or not include. 2 is not included. The number 2 is not included. Okay, so if a real number is greater than or equal to 2, so if 2 is included, then we will use a bracket. Okay, bracket. So in this case, use parentheses because the number is not included. Okay, how about graphing the real numbers between negative 3 and 0? Okay, negative 3 is this one, right? And 3 is this one. So between these two numbers is over here, right? So these are the numbers between negative 3 and 0. So you highlight it, make a bold line segment like this, and negative 3 and 0 are not included. If let's say exclusively, then we don't include this number. So we will put what? Parenthesis around this. So when you put a parenthesis, always put a parenthesis towards the direction of the solution. The real number part. So the real numbers are greater than negative 3, right? Greater than negative 3. So put a parenthesis opening towards to the right, and then 0. The parenthesis on 0 side is what? Closing parenthesis. So this one is actually opening towards to the left, right? So opening like this or like this. If it is between, then it looks like this. If it's less than, then it looks like this, or if it's greater than, the parenthesis looks like this. Okay, so this is incorrect. This one is incorrect, not right, and even this one is not right. Okay, and then also this and this is incorrect. Okay, make sense? Alright, so don't forget this, either this, this, or this. So the parenthesis is always opened towards the direction. Okay, an inequality contains the symbol, the inequality symbols, greater than, less than, greater than or equal to, or less than or equal to. So if an inequality expression contains this, then we call it an inequality. So for example, okay, here is x and then less than 3. So we read this one as x is less than 3, or less than 3. How about this one? X is less than 3, but also there's equal sign. So we can put the less than and equal together. So x is less than or equal to. Here is or, okay, not and. So x is, I don't know what x is. X is a number, right? It's a real number that is less than or equal to 3. So less than or equal to, these two are combined using the or. Okay, how about this, the next one? X is greater than 3. Definitely this is just a greater than 3. All real numbers, that is greater than 3. So if there's equal sign, then this is what? X is greater than or equal to 3. So if there is or, then either less than or equal to is satisfied, then the inequality is true. So look at this. 5 is less than 5. This is not true, right? This is false, because 5 is equal to 5. Right? 5 is equal to 5, not less than. So this one is false, but 5 is less than or equal to 5. Then this is true, because 5 is less than 5 is false, right? But the conjunction is or, right? Or, so 5 is equal to 5. This is true, right? This is true. So it's either 5 is less than or equal to 5. Less than is false, but equal to is true. So since 5 is equal to 5, the result is what? True. Make sense? So you have two conditions, condition A and condition B. So if either A is true or B is true, either A is true or B is true, then the result A or B is true. Okay, so if x is 4, let's say x equals 3, then 3 is greater than or equal to. So greater is not false, but equal to is true, right? 3 is equal to 3. So the result of this inequality is true. Okay, I hope you got this. Okay, how about this? Okay, x is greater than 1. So graph x is greater than 1. So x is a number. X is any real number, all real numbers that is greater than 1. So all the numbers right off 1, the number 1. So you can put a solid line to the right of this number 1, right? Number 1. So all the numbers in this purple line is greater than 1, right? And 1 is not included, so we put parentheses. Remember, put parentheses. So all real numbers greater than 1 should be this one. So x is greater than 1. So when you graph x is greater than 1, that means, okay, think what number is greater than 1. So they are the numbers right off the number 1, right? Right off the number 1. So make a bold line on the right part of the number 1. And since 1 is not included, use a parenthesis. How about this? x is greater than or equal to 1. So there are two conditions, greater than 1. So greater than 1 means numbers, x are the numbers placed right of 1, right? Lies right of 1. So put a borderline on the right side of 1. Okay, and since there is equal sign, okay, for the equal sign means 1 is included. So then use what? Bracket. Okay, bracket. So greater than means just put the borderline on the right of the number 1, and equal to means include 1, right? Include 1. So in that case, we use a bracket. So bracket means the end point. Oh, sorry, this is 0, right? 0 should be 1, right? Should be 1. Sorry. So it should be starting from 1 and all the way to the right. And this is 0, right? Okay, and next example. Okay, for the inequality x is less than or equal to -6. So x is all the numbers that is left of -6, and also -6 is included. So which value of the variable? So x can be, there are so many values of the variable x, right? So which number listed below make that inequality true? So that means, these are the x values. So plug in x value to the variable y and check whether the inequality is true. So -12. So let's put replace the variable x with the given number and check the inequality. Is this true? So -16 is now left of -6. So this is true, right? True. So yes. Yes, so -12 is less than -6. How about this one? Is -6 less than or equal to -6? Yes, because -6 is equal to -6, right? Equal to. So this is also true. How about 0? Is 0 -6? This is false, right? False. False means the inequality is not true because 0 is greater than, because 0 is right of -6. So this is false. And then square root of 5. Is square root of 5 is less than -6. This is false, right? False. Why? Because square root of 5 is 2 point something. It's positive number. So positive number is always right of negative number. Can you see it? So this is the number. Let's say this is number 9. And here's 0, right? 0, 1, 2, 3, 4, 5, 6. -6. And so on, right? Somewhere there is -12. So here is -12. So -12 is left of -6, so this is true. And 6 is same as 6, so -6, so this is true. So -6 is equal to -6 is true. How about 0? 0 is right of -6, right? So 0 is greater than -6. So this statement is false. 1, 2, 3, 4. And then square root of 5 is 2 point something, somewhere over here. This is square root of 5, right? So square root of 5 is right of -6, so square root of 5 is greater. So this inequality is false. Okay, so -12 and -6 make the inequality true. Okay, how about for word problems? How about, okay, whenever we have at least and at most. So x is at most 3. Then the inequality for this is, at most means maximum, right? The maximum value of a is 3, right? 3. So x has to be always less than 3. So at most means maximum value, right? So the maximum value of x is 3. So look at the number line. 3 is the maximum number, right? So x is less than this 3. So you can write it as this. X is less than or equal to 3. So this is the inequality representing this sentence. X is at most 3. So at most means the value of x is, the maximum value of x is 3. So all the value of x is less than. Okay, less than. Okay, how about this one? X is at most 3. At most means, oh sorry, at least. Did I say at most? Okay, so at least 3. Okay, at least 3 means, the smallest number, the minimum number of x is 3, right? The minimum number. So x is always greater than or equal to the number 3. So look at the number line. So at least 3 means the minimum value of x is 3, right? 3. So the numbers has to be right of this number 3, all the way to the right. So you can write it as this: x is greater than or equal to 3. So if you have a word like at most means maximum. Okay, maximum of the variable x is 3. So all the numbers of x is less than. Okay, less than. So at most means maximum, and then at least means minimum. Okay, minimum. So minimum means numbers are greater than the number, right? Greater than or equal to the number. And at most means the maximum is 3. So the numbers are less than or equal to the number. Okay, so let's check this application. The minimum wage at a company you work is $9.25 an hour. So the minimum wage, minimum means what? The smallest, right? The smallest. So the minimum wage is x. Let's say this is x, right? So x is, the minimum is $9.25. $9.25 is the smallest number, right? Smallest amount. So it's gotta be greater than or equal to. Make sense? So the inequality for this wage is x is greater than, so minimum, right? Minimum is the smallest. So at least. So the wage is at least $9.25. So it's gotta be $9.25 or more, right? More. So look at this. It's number 9, right? Number 9, 0. This $9.25. So it's gotta be $9.25 or more, right? $9.25 or more. $9.25 or more. So that is x, right? X. So you can write it, x is greater than or equal to. Greater than or equal to. Alright, then let's check whether $9.15 an hour is possible. So plug in $9.15 and let's check if this is true. Okay, $9.15 is over here, right? This is $9.15, right? $9.15. So $9.15 is less than $9.25. So this is false, right? False. So no, right? No. So $9.15 is not possible. It's not a possible age, right? Possible wage. Okay, so it looks like we are done for this section.